This is question number 51 of set 1 of GATE Mechanical Engineering 2019. The question says, the value of the following definite integral is, we are given the integral from 1 to e x ln x dx, and we need to find the value rounded off to the 3 decimal places. So the given integral here is, let's say I is equal to 1 to e x ln x into dx. This has two functions. This is the first function and the second function. So if you need to evaluate these type of integral, like the multiple of two functions, so the easy way to do it is using integration by parts. Now let's understand what is integration by parts and how do we perform that. Now according to the integration of by parts, suppose you need to find the integral of multiple of two functions, suppose f of x and g of x into dx. So this can be done using the formula, that is f of x into integral of g of x dx minus integral of d upon dx, that is differentiation of first function f of x into integral of second function g of x dx whole, because we are integrating the whole, we write here, let me write here dx. So here f of x is the first function and g of x is the second function. So in integral by parts, to select the first function we follow certain rule, and that is called ILAT, I-L-A-T-E. Here I stands for inverse function, L stands for logarithmic function, A stands for algebraic functions, T for trigonometric function, and E for exponential function. So if we have two functions, that is multiple of two functions f of x and g of x, so now suppose f of x is the first function and g of x is the second function. So to select the first function, which one we will consider for this formula, which one we consider the first function, that will be in this order. Suppose you have one inverse function and one algebraic function, so always consider the inverse function as the first function and algebraic function as the second function. Now suppose if you have algebraic function and trigonometric function, so we will consider the algebraic function as first function and the trigonometric function as second function. It's not like we cannot solve the integral if we select the first function and the second function randomly or in a random order, like we can select the first function algebraic and say first function algebraic and second function inverse. But using this method, or if we select the integral in this order, it will make the problem easier to solve. And if we select it randomly, sometimes it's very difficult to solve those type of integrals if we select the first function and second function in different order other than this. Now let's see in our given problem, how do we find the integral using the method integral by parts. So the integral given to us is integration from 1 to e x into ln x into dx. Now let's say this is I. Now we can see here this x is algebraic function and this ln x is logarithmic function. So according to the rule explained above, we shall consider the first function as, now we will consider f of x as ln x and the second function, that is g of x, as x. So this is our first function and this is second function. Now if we consider in this order, this integral will be very easy to solve. Now by using integral by part, this integral, the above integral can be evaluated as I is equal to the first function, that is ln x, integral x into dx, the second function, minus, so the differentiation of the first function d by dx of ln x into integral of second function, so x dx and the integral of whole. Now this integral can be written as, So the first function ln x will remain as it is. Integration of x is x square by 2 minus, now this integral sign we will keep as it is. Now differentiation of ln x we know is 1 upon x multiplied by the integral of x, that is x square by 2 into dx. So here if this x, 1x we can cancel out. So again we can write it as, let's write like this, x square by 2 ln x minus, now integration of here 1 by 2 we can take outside, and integration of x dx will be x square by 2, right? Now the integral, our integral will become I is equal to, that we have found out just now, x square by 2 ln x minus x square by 4, and we have to put the limit from 1 to, see in the question it is given the limit is from 1 to e. Okay, so let's put the limit. The lower limit is 1 and the upper limit is e. First upper limit, if we substitute, we get e square by 2 ln e is 1, so into 1 minus e square by 4. Now we will put the lower limit minus, so ln 1 is 0, so this whole function, this value will become 0, and this here will become minus 1 by 4. So here e square we can take common, in bracket it will be 1 by 2 minus 1 by 4, that is 1 by 4, so we can write e square by 4 plus 1 by 4. Now using calculator, if we try to find the value of this e square by 4 plus 1 by 4, we will get I is equal to 2.097. Since we need the value of integral to be accurate to 3 decimal places, so we will write 2.097. Now let's go back to the question. So the value of integral will be 2.097, and this will be our final answer. Now to see the derivation of integration by parts and to get more information on integration, you can follow the NPTEL course of Basic Calculus for Engineers, Scientists and Economists by Professor Joydeep Datta of the Department of Humanities and Social Sciences, IIT Kanpur. Hopefully I was able to clear it out. Have a great day.